All right, here's the second example. So here we have a polynomial and it's in standard form, right? We have descending order and it's set equal to 0. So that is the standard form of a polynomial right there. That's the formula for it. And then here is our polynomial right here. So basically, what we would normally do to solve this equation is to actually put this in factored form. We would factor it out. Let's see what happens if we try to do that. So we'll go ahead and set up our parentheses, set it equal to 0, split up our first term. The signs are going to be opposites, right? What multiplies to make -3 but adds to make -6? We know 3 is prime, so only 1 and 3 go into it, right? And the greater number would have to be negative. So -3 times +1 is -3. But when you add them together, there's no way you can ever get -6. So we actually have an equation, a polynomial, that is unfactorable. So the only way to actually solve this is to do, well, there's two ways to do this. We could complete the square, or we could use the quadratic equation. And since we haven't learned how to use the quadratic equation yet, we're going to go ahead and complete the square. So let's learn how to do that. Basically, what you're going to do is step 1, make sure it's in standard form, right? That's step 1. Standard form. Now step 2 is to move the constant to the right side. Okay, so our constant in this case would be -3. So if we move that to the right side, we have to add it to both sides, right? So here we have x squared minus 6x is equal to 3. And notice I left a space. I did that so that we could do step 3. Step 3 is to actually complete the square. Now the formula for that is b over 2 squared, and we're supposed to add that to both sides. So on this side over here, we're going to take b, our b term, right? That's the middle term, -6 in this case. And we're going to divide it by 2, so we'll add -6 over 2 squared. And if you do it to one side, you have to do it to the other. That's the golden rule. So that's why we say we're adding that to both sides. All right, so 6 divided by 2 is 3, and if you square a negative, it's gone. So 3 squared is 9. So really, we're just adding 9 to both sides. And 9 plus 3 is 12. So that is our new polynomial, right? Once you have completed the square, know that you always have a perfect square trinomial. We have our first term squared, our last term squared. The middle term is 2 times a times b. So if we are to put this in factored form, we can use our formula for a perfect square trinomial. So a perfect square trinomial, what is the formula for it? Let's review that. We have a squared plus 2ab plus b squared, right? That is equal to a plus b squared. And then the other form is if the middle terms are both negative. So these are the two different cases of a perfect square trinomial. In this one, we have the middle terms negative, so we have the second case. That means our factored form is a minus b squared. So our a term is this x squared. If we take the square root of x squared, we get x, right? That's what a is. And b is the square root of 9. So we have 3. Since this is minus in the middle term, we use the formula with the minus sign. And that is the factored form. So that is equal to 12. Now we do what we did in example 1. We're going to extract the square root. That's the quick way to do this. So take the square root of both sides, and now we'll have x minus 3 is equal to plus or minus the square root of 12. We need to simplify this radical because it does simplify. The perfect square that goes into 12 is 4. So square root of 4 and square root of 3 make square root of 12. Square root of 4 is 2, and square root of 3 is prime, so it stays. Now to get x by itself, we're going to add 3 to both sides. And there we go, you just completed the square. So step 4 would be basically to simplify or solve for x. after converting it into from your perfect square trinomial into its factored form. Okay? All right, so example 3 we will do in the next video because it's hard to load these up.